Hey, what is going on? This is your immune system lecture of the day. I'm glad to have you here. It's January 11th, 2022, and let's get started. We've got a lot to discuss. Not too much today. I'm going to have a short lecture actually, but one thing that we've been focused on, or one path I've been focused on in my previous lectures, is that I've been mostly talking about the immune system at the cellular level and even at the genomic level in certain cases, going as far down into the level of looking at transcription factors and toll-like receptors and other important pieces of the immune system that are functioning molecularly and chemically. But the thing is, today I'm going to take a step up, take a step back, and talk about the immune system from a higher systems level of understanding, because it's kind of important, because that's essentially what is the level that people interact with the most. Okay, so the immune system is divided into the innate immunity and acquired immunity. Okay, so the innate immunity and acquired immunity basically are the two parts of the immune system we've been talking about to a large extent already. Your innate immune system activates right away as soon as the immune system kicks in, right? So as soon as a pathogenic infection kicks in through a wound or through a mucous membrane ingestion, things like that. And that involves your mast cells, your dendritic cells, your macrophage, neutrophils, and all your lymphocytes kind of converging on the site of infection through an inflammation and immune response that's produced through the release of histamines, etc. Okay, so that's your innate immune system, and it also involves your complement system. Your acquired immunity, right, comes from your adaptive immune system, and that's what helps you throughout your entire life, preventing diseases from killing you, essentially. And you can divide that at a systems level into two separate versions, which one is your active acquired immunity and your passive acquired immunity. So your active acquired immunity essentially is what we've been talking about mostly at the cellular level, what happens naturally when pathogens enter your system. Antibodies are made after exposure to an infection. So that's basically when your T cells are activated, your T turn into T effector cells, right, through the detection of these antigens that macrophages have ingested and then have presented to them, right? And then your T cells go on to activate your B cells. Your B cells produce plasma cells and memory cells, and then your memory cells contain the antibodies. They contain antibody copies for when an infection occurs the first time and then occurs the second time, and those copies of antibodies are then released and then deal with the infection that has occurred the second time. So that's immunity conferred through the entire standard process of pathogenic ingestion, through phagocytosis and antigen detection, etc., and then reinfection. And then there's no interference of a person other than yourself involved in this. So there's also the artificial version of antibodies-based immunity, right? So this artificial version is when you're vaccinated, okay? And vaccinations have had a lot of talk in the media, etc. And people are against them, for them. Who cares about that right now? We'll just talk about what happens when you're vaccinated. An inoculated version of the pathogen is introduced into your system, into your body through an injection, and this inoculated version of the pathogen has less infectious power through several means, right? Then this is an entire science, an entire huge industry that's done per infection to inoculate these pathogens. But this weaker version of the pathogen has just a small percentage of this antigen, enough to activate your T cell and B cell, etc. production of antibodies, and then allow the plasma cells to be created, which then create antibodies which will fight an actual version of the infection later on. Through vaccinations, your immune response is much weaker, and you don't have as strong of an antibody response initially, but that's fine. That's just like how it works and the general theory of it. So that's how active immunity is introduced. Passive immunity is introduced through another mechanism. So passive immunity is an immune response that's it's not meant to stay with you. So it's essentially when someone else lends you their antibodies. Typically, it's the mother lending antibodies from their own system to a baby's system, right? So the antibodies come from a mother's milk, right? And they are tempered. There's only a limited number of them. So once they're introduced into the fetus, in the case of when the child is in the body, then they flow through the placenta, and these are the antibodies that are small enough to do so, and they circulate in the fetus's blood and lymph, and they fight infection that way until the fetus will eventually develop methods of fighting infection on their own. And then once the fetus is born, breast milk is another way of conveying immunity, temporary immunity, through this passive mechanism to the child, right? So that's something that's done for a while, and until the child develops their own immunity through the standard mechanisms of T cell building up of T cells, etc. The whole process of effector cell and humoral immunity buildup. So that's how natural passive immunity is conferred. And then you have the artificial method, which is kind of like vaccination, but it's basically introduced through medicine, where you, for example, have obtained some like monoclonal antibodies or things like that, and those are temporary, and those fight the infection in your system, but you don't develop your own antibodies based on that. That's typically what I think is the process of how you deal with a very strong infection right away. That you don't have time to wait for antibodies in your system to form. You don't want the infection to ravage your system while antibodies are being created, while your immune system is adapting, which is basically why you have the whole latent phase, logarithmic phase, and fall off phase for your typical immune response. You just need it dealt with right away. So that's basically the temporary artificial way of doing so. So those are your kind of branches of your acquired immune system, and I'm going to leave it here for now, but I'll be talking about the mucosal immunity later on, because the immune system is systemic in a large part, involving organs like your spleen and other organs, your lymph organs, etc., your lymphoid tissue. But your mucous membranes are really the most important part of your immune system, because they're the first interface through which pathogens typically invade. And there's a lot, and 75% of your immune cells are actually stored in your mucous membrane, and live in your mucous membranes, which are throughout your entire body. So that's what I'll be talking about next. So for now, I'll see you around. Have a good day, and come back again. Bye.